Okay, gang, welcome back. Here we are on page 51, making a correction. This should be minus infinity, this should be 1/2, and this should be 0. I think I just changed the order of the questions and forgot to change the answer key. So this is what you were pointing out before, right? You said minus infinity was that first one. Yeah. Okay, so that's at the top of page 51. Let's go ahead and make those changes. So as you know, today is our review day for test number 3, which is coming up on Monday. The test is on everything since the second test. It's not going to explicitly go out of its way to test you on earlier material in the semester, but you know, like you still need to know how to do the product rule and the chain rule, even though those were things we tested earlier, right? So the highlights are here in between the two tests, but of course it's a cumulative subject by nature. So the test is on Monday, and then we got 4 more days of new stuff before a couple of review days, and then the final exam. Questions on the calendar? Yeah. Okay, a very broad overview here on the next page. Subject areas for the test: related rates, implicit differentiation, families of curves, L'Hopital's rule, linear and quadratic approximations, and then 2 named theorems, the mean value theorem and the racetrack principle. It's a pretty short list, but the fact is several of those topics are among the hardest of the entire semester, and that's what happens near the end of Calc 1. It used to be that optimization problems were also put here, and this is why Caitlin and I decided to change things and sprinkle the optimization throughout, try to relieve the difficulty at this test. There is a much more detailed list in the study guide. It's on the next page. For each item in that list, try to figure out what kinds of questions I might ask that are related to that item, and make sure you know the process for answering those kinds of questions. For example, here's one thing that's on the next page. I just copied it here. It says find the local linearization and quadratic approximation of a differentiable function and use it to estimate values for a function. It's a lot of words, but I'm hoping that we're starting to get some memories about what kinds of problems we did that would fit under this category. And so, for example, it could be something like f of x equals, I don't know, e to the 5x. Maybe that's the thing we are trying to approximate, either with a straight line or a quadratic, a parabola. And then we have to be given an x value, x equals 0, or maybe it was called a, I don't remember. And so then there was a process, and the process for the quadratic approximation was to always start, I'll just name it q of x, but we just always started with a generic quadratic function. And the goal is to find the values of a and b and c to make that blue function look as good as possible, as close as possible to that black function near x equals 0. And it was a process, and the process involved finding the first derivative of both functions, finding the second derivative of both functions, and then plugging 0 into 6 different functions. 1 and 2 are here. First and second derivatives are the other 4 functions. You plug 0 into 6 functions, and then you make them equal each other in the right way, right? You need f of 0 to equal q of 0, and f prime of 0 to equal q prime of 0, and f double prime to equal q double prime. And that gives you 3 equations with the a, b, and c, and then you find a, and you find b, and you find c. If you can get to a place where you can just recite the process like I just did, well, you're in good shape. Like, you really understand what I'm talking about in that bullet point there. But for anything that you're not clear, like either I don't know the process or I don't even know what kinds of questions Ian is talking about, that's something you got to ask, right? Or look up in the notes, hey, what kinds of things apply to this topic, okay? All right, things to know about the test. You can use a 1-page sheet of notes. You should keep it because you can bring it with you to the final exam along with your other reference sheets from the first 2 tests. And you can also use one of my sheets. It is the guideline for related rates. It was page 3 of your packet, okay? So you can rip it off now, or you can bring it on Monday and rip it off then. Right, so 2 pieces of paper for Monday's test. Scientific calculator, not a graphing calculator, not your phone. I can lend you one if you need one. The test is written to be 1 hour long, but you can take more. Our window is 10 until 12 on Monday, so come right after physics if you're in physics, but aim for a 10 o'clock start, maybe even 9:55, so you're ready to go at 10 o'clock. Any questions generally? Ryan? Yeah. So that's a good question. What kinds of things did you have in mind? So why don't you just put all the notes on your other sheet of paper. Okay, thank you. Other questions? You can put them on the other sheet too. Yeah. Other questions? All right, so I'm going to make a slight change in the advice that I give. I've always been saying, you know, the practice problems, the sample test problems, which are on the next page, are a good use of your time, and I still am saying that. But I've also said, hey, if you want to make your reference sheet, or if you just want to kind of study or like read or something like that, then you can use the next hour to do those things, and you can, but that is not my recommendation. My recommendation is that you are here doing problems, not reading, not making a reference sheet. Like, you can do those things more productively on your own when you don't have the resources here to help you to do problems, right? That's the way that we know that we're where we need to be, is to do problems. So my strong recommendation is that you do problems. Study guide problems are good, activity problems are good, homework problems are good, but maybe spend the next hour doing problems, not making a reference sheet, not reading. And raise the flag, I will walk around.